Can James Webb track objects in our solar system? The James Webb Space Telescope has captured stunning images of our solar system, including nebulae, galaxies, and even the deepest views of the universe. Now the telescope has turned its eye towards something much closer to home, our own solar system. The new images show Jupiter, Saturn, and their moons in unprecedented detail, providing scientists with a wealth of information about these familiar planets. In addition to their incredible beauty, these images will help us to better understand the formation and evolution of our solar system. With each new image taken by the James Webb Space Telescope, we are getting a clearer and more detailed view of the universe around us. And what about the solar system? Can the James Webb image the objects in our solar system? Let's understand how the James Webb can track solar system objects in this video. The internet erupted when NASA unveiled the first of the incredible photographs obtained by NASA's James Webb Space Telescope. The James Webb Space Telescope is the largest telescope made by man and can capture amazing images of space. It was put into orbit in December of 2021. The primary mirror in the James Webb Space Telescope is 6 times larger than the ones used in the Hubble Space Telescope. James Webb Space Telescope is also more sensitive to infrared waves than Hubble. This allows the James Webb to detect objects that are too faint for Hubble to see. The James Webb will allow astronomers to study the universe in greater detail than ever before. The James Webb Space Telescope, when combined with bigger mirrors and greater sensitivity to infrared wavelengths, can see considerably further into space than any previous telescope. In fact, NASA has verified that it is capable of observing things that even Hubble cannot detect. NASA's James Webb Telescope is made to observe and reveal the deepest secrets of our universe, but it can also track and image objects in our solar system. Earlier in May of 2022, NASA's Next Generation Space Observatory successfully saw a moving asteroid. The successful monitoring of a local object demonstrates that the James Webb Space Telescope can keep an eye on solar system objects, as well as the distant galaxies, stars, and other distant objects that it is intended to study throughout its potentially 20-year existence. As we go with Webb's observation, we will test other objects traveling at different speeds to ensure that we can investigate things moving across the solar system with Webb. Webb's capacity to view close targets will enable it to investigate anything from frozen objects in the Kuiper Belt to possibly habitable moons surrounding our solar system's gas giant planets. We saw a hint of Webb's amazing capability in observing solar system objects. Members of the James Webb team photographed Jupiter while calibrating the equipment to determine if it can be used to examine neighboring astronomical objects, such as moons and asteroids, as well as other features such as planet rings and satellites. The James Webb Space Telescope captured an incredible image of Jupiter and its moons, providing new insights into the gas giant's distinct bands and the Great Red Spot. The photo was taken by the telescope's near-infrared camera, NIRCam instrument, using the short wavelength filter. The Great Red Spot is clearly visible in the image, even though it appears white due to the way the image was processed. When the NIRCam's instrument's 2.12 micron filter was used, the resulting image showed the Jovian moons Europa, Phoebe, Matisse, and even Europa's shadow near the Great Red Spot. This new view of Jupiter provides valuable information about the planet's atmosphere and how it interacts with its moons. The James Webb Space Telescope, or JWST, is best known for its ability to peer into the deepest recesses of the universe. However, scientists will also be using the telescope to study our own cosmic neighborhood in greater detail. The space agency recently revealed the telescope's images of the planet Jupiter, as well as an asteroid, used as reference targets when engineering teams were calibrating the observatory's instruments. The pictures serve as a small teaser of the images we should be getting from our solar system in the months and years to come. With its unprecedented ability to collect light and resolve fine details, the James Webb Space Telescope promises to revolutionize our understanding of the solar system and beyond. Jupiter and its rings, as well as 3 of its moons, Europa, Thebe, and Metis, are seen in the image released by NASA. The shadow of Europa may also be seen in the picture on the left, right near to the planet's notorious Great Red Spot. James Webb observed Jupiter as part of a test to ensure that JWST could track fast-moving objects through the solar system. This test also showed that it's possible to use JWST to photograph details like moons and rings around a planet as bright as Jupiter. Observing a bright planet and its satellites and rings was expected to be challenging due to scattered light that may affect the science instrument employed, but also the fine guidance sensor must track guide stars near the bright planet. However, the images taken by JWST's near-infrared camera, NIRCam, suggest that these challenges can be overcome. The images use 2 different filters which highlight several wavelengths of light, and they show that JWST is capable of capturing incredible detail. Jupiter was the slowest moving of the 9 targets photographed, but it is also one of the most stunning. The test has provided valuable insights into the capabilities of JWST, and it has shown that this telescope is capable of making groundbreaking discoveries. We all know the James Webb Space Telescope is designed to study distant objects in space, but it needed a test subject that was a little closer to home. So, JWST engineers pointed the telescope towards Jupiter and snapped some pictures. These images were used to test the telescope's ability to focus on distant objects and collect data. They also allowed the engineers to calibrate the telescope's instruments. The pictures of Jupiter aren't as sparkly as the full-color photos of nebulas and galaxies that NASA released this week, but they do show the kind of precision we can expect from JWST's images of the outer solar system. Jupiter's iconic storm feature, the Great Red Spot, can be clearly seen in the photos, as well as the planet's icy moon Europa, and Jupiter's thin rings, which often go overlooked in images of the gas giant, make a very faint appearance. The James Webb Space Telescope will provide unprecedented opportunities for observing planets and moons in our outer solar system, and in particular for searching for signs of possible life. The images released by NASA show that JWST will be able to see relatively faint objects such as the rings and moons surrounding particularly bright planets like Jupiter and Saturn. This is important because many of these moons are thought to harbor liquid oceans beneath their surfaces, making them potential habitats for life as we know it. In addition, the James Webb Space Telescope will also be able to observe fast-moving objects such as asteroids, comets, and others. This is important because it will allow us to better understand the dynamics of our solar system and the potential threats posed by these objects to life on Earth. Ultimately, the James Webb Space Telescope will be a powerful tool for understanding our place in the universe and seeking out the mysteries that remain hidden in the depths of space. The James Webb Space Telescope is designed to observe objects in space over a very wide range of wavelengths, from the ultraviolet to the infrared. One of its key science goals is to study the formation and evolution of galaxies. To test this ability out, the commissioning team locked onto an asteroid in the asteroid belt between Mars and Jupiter, proving they could keep an eye on it with JWST. Ultimately, they found the observatory can keep track of objects moving twice as fast as what they expected to be able to track. It's similar to photographing a turtle crawling when you're standing a mile away. This is all good news as it means JWST will be useful at tracking things like near-Earth objects and comets. Overall, the commissioning report shows that JWST is performing even better than expected. The main result of 6 months of commissioning is that JWST is fully capable of making the discoveries for which it was designed. The JWST mission was intended to allow important advances in our knowledge of the genesis and development of galaxies, stars, and planetary systems. So what do you think about the capability of the James Webb Space Telescope? Let us know in the comments below, and be sure to watch our other videos about JWST through the YouTube end screens and playlists.